Continue. Yeah. All right. So we have reached think the comparison. We added the guess. Where did we reach? Here. Yep. Okay, we create a variable named guess, but wait, doesn't the program already have a variable named guess? It does, but Rust allows us to shadow the previous value of guess with a new one. This feature is often used in situations in which you want to convert a value from one type to another type. Shadowing lets us reuse the guess variable name rather than forcing us to create a unique variable such as guessr and guess. For example, chapter 3 covers shadowing in more detail. We bind guess to the expression guess trim parse. Guess in the expression refers to the original guess that was the string with the input in it. The trim method on a string instance will eliminate any white space at the beginning and the end. Although unsigned 32 can contain only numerical characters, the user must press enter to satisfy read line. When the user presses enter, a new line character is added to the string. For example, if the user types 5 and presses enter, guess looks like 5/n. /n represents new line, the result of pressing enter. The trim method eliminates /n, resulting in just the 5. The parse method on strings parses a string into some kind of number. Because this method can parse a variety of number types, we need to tell Rust what exact number the type we want by using let guess unsigned 32. The colon after guess tells Rust we'll annotate the variable's type. Rust has a few built-in number types. The unsigned 32 seen here is an unsigned 32-bit integer. It's a good default choice for a small positive number. You will learn about other number types in chapter 3. Additionally, U32 annotation in this example program and the comparison with a secret number means that Rust will infer that a secret number should be a U32 as well. So now the comparison will be between two values of the same type. The call to parse could easily cause an error. If, for example, the string contained a thumbs up %, there would be no way to convert that to a number. Because it might fail, the parse method returns a result type, as much as the readline method does, discussed earlier in handling potential failure with the Rust type. We'll treat this result the same way by using the expect method again. If parse returns an error result variant because it couldn't read the number from the string, the expect will crash the game and print the message we give it. If parse can successfully convert the string to a number, it will return OK variant of result, and expect will return the numbers that we want from the OK value. Nice. Even though spaces were added before the guess, the program will figure out the user guessed 76. Run the program a few times to verify different behavior with kinds. Okay, guess the number correctly, guess too high, we have most of the game working now, but the user can only make one guess. Let's change that by adding a loop, allowing multiple guesses with a loop. The loop keyword creates an infinite loop. We'll add that now to give users more chances at guessing the number. Loop. So yeah, as you can see, we moved everything into a loop from the guess input prompt onward. Be sure to indent the lines inside the loop another 4 spaces each and run the program. Notice that there is no problem because the program is doing exactly what we told it to do. ask for another guess forever. It doesn't seem like the user can quit. The user could always interrupt the program by using the keyboard shortcut Control C, but there is another way to escape this insatiable monster. As mentioned in the parse discussion, if the user enters a non-number, the program will crash. The user can take advantage of that in order to quit, as shown here. Quit, yeah. Typing quit actually quits the game, but so will any other non-number input. However, this is suboptimal, to say the least. We want the game to automatically stop when the correct number is guessed. Quitting after the correct guess. Okay, let's program the game to quit when the user... Okay, let's add the loop first. Okay. Okay, I guess I have these are actually um okay. Adding the break line after a while makes the program exit the loop when the user guesses the secret number correctly. Exiting the loop also means exiting the program because the loop is part of main. Handling invalid input. This is the last bit. Yeah. To further refine the game's behavior rather than crashing the program when the user inputs a non-number, let's make the game ignore a non-number so that the user can continue guessing, while we do that by altering the line where guess is converted from a string to 32. Yeah. Match on the parse. If it's okay, none. If it's error, continue. Okay. Okay. Switching from an expect to a match expression is how you generally move from crashing an error to handling the error. Remember that parse returns the result type. Result is an enum that has variance OK and error. We're using a match expression here as we did with the ordering result compare method. If parse is able to successfully turn the string into a number, the OK, what will return an OK value, contains the resulting number. That OK value will match the first arm pattern, and the match expression will just return the num value that parse produced and put inside the OK value. That number will end up right where we want it in the new guess variable we are creating. If parse is not able to turn the string into a number, it will return an error value that contains more information about the error. The error value does not match the OK number pattern in the first match arm, but it does in the error underscore in the second arm. The underscore is a catch-all value. In this example, we're saying we want to match all error values, no matter what the information they have inside. So the program will execute the second arm's code. Continue, which tells the program to go to the next iteration of the loop and ask for another guess. So effectively, the program ignores all errors that parse might encounter. Now everything in the program should work as expected. Let's try it. Okay, awesome. With one final tweak, we will finish the guessing game. Recall that the program is still printing the secret number that worked well for testing, but it ruins the game. Let's delete the println that outputs the number. Okay. At this point, you've successfully built the guessing game. Congratulations, this project was a hands-on way to introduce you to many new Rust concepts. Let, match, methods, associated functions, the use of external grades, and more. In the next few chapters, you will learn more about these concepts in more detail. Chapter 3 covers concepts that most programming languages have as variables, data types, and functions, and shows how to use them in Rust. Chapter 4 explores ownership, features that makes Rust different from other languages. Chapter 5 discusses structs, methods, syntax, and Chapter 6 explains how enums work. Common programming concepts. This chapter covers concepts that appear in almost every programming language and how they work in Rust. Many programming languages have much common at their core. None of the concepts presented in this chapter are unique to Rust, but we will discuss them in the context of Rust and explain the conventions around using these concepts. Specifically, you will learn about variables, basic types, functions, comments, and control flow. These foundations will be in every Rust program, and learning them early will give you a strong core from the start. Keywords. Rust language has a set of keywords that are reserved for use by the language only, which are much as other languages. Keep in mind that you cannot use these words as names of variables or functions. Most of the keywords have special meaning, and you will be using them to do various tasks in your Rust programs. A few have no current functionality associated with them, but have been reserved for functionality that might be added to Rust in the future. You can find a list of the keywords in Appendix A. Wow, that's a lot. Abstract, become, box, do, final, macro, override, private, try, type of unsized virtual yield. Variables and mutability. As mentioned in chapter 2, by default, variables are immutable. This is one of the many nudges Rust gives you to write code in a way that takes advantage of the safety and easy concurrency that Rust offers. However, you still have the option to make your variables mutable. Let's explore how and why Rust encourages you to favor immutability and why sometimes you might want to opt out. When a variable is immutable, once a value is bound to the name, you cannot change that value. To illustrate, let's generate a new project called variables in your projects directory by using cargo new variables. Then in new variables directory, open the main, replace the code in the following. Okay, won't compile. Let x equals 5, x equals 6, it won't compile. Sure. This example shows how the compiler helps you find errors in your program. Even though compiler errors can be frustrating, they only mean